Search the smallest entry in a sorted array that is rotated. What is a sorted array that is rotated? Let's look at this array. You can see this array is originally sorted. It's sorted from here to here, and it is sorted from here to here. And this last element is smaller than the first element. So if you do a cut and paste and put it here, you get a sorted array. So this is an array that is sorted and rotated, specifically rotated at this point. All the elements are unique. Return the index of the smallest element in login time. Array is not empty. This is not a lead code question, so I'm going to prepare my own test cases. In the first question, the smallest number, the index is 6. 1, 2, 3, 4, 5, 6. Second test case, 2. You can also see it is rotated at this point because this number is smaller than the first number. The third case, there's no rotation, so index is 0, so on and so forth.
Pause the video and see if you can solve it. Since the question asks for a login time solution, you know this is binary search. A binary search always involves a low index, which is 0, a high index, which is the length of the array, -1, and some sort of a query where you query on the mid number. The mid is low plus high over 2. And from that query, you make a decision, you go left or right. Please do not complicate the question. There are only 3 cases. The first case is your array, there's no rotation, so it is perfectly sorted. And I've already labeled the index from 0. So assuming low is 0, high is 6, so you're doing query on mid, which is 0 plus 6 over 2, which is 2. So this is the query point. You want to make a decision, go left or right. How do we know if this whole array is sorted? You cannot know that, but what you can know is whether the right half is sorted. How do you know that? You compare the mid against high. If mid is less than high, we know the right half is sorted. Because the right half is sorted, if you want to find a smaller number, find smaller, you go left, right? Another case is when there is a rotation and the smaller number occurs on the left. So you are doing the query on mid, which is 0. This is high, this is low. There is a rotation. As a result of the rotation, the smallest number is on the left of what you are querying. It's the same thing. You just compare mid against high. If mid is less than high, you know the right half is sorted. So if you want a smaller number, you just go left. The third case, there is also rotation, but the smallest number is on the right. The mid is 4. This is what you're querying. Now you compare mid against high. Now your mid is greater than high. What that means is there's a rotation on your right. Because there's only one rotation in the entire array, you know the right, there's a rotation, so your left is definitely does not have rotation. Your left is definitely sorted. So we just go right. If mid is greater than high, just go right. The reason being, you know for sure the right is not sorted, so your left is sorted. And in order to return the final result, which is the index of the smallest number, you just need 2 global variables, a minimum number and the index of that number. You will keep overriding these 2 every time you visit a mid number. So let's code it out in C++. I have prepared 10 test cases. I'm gonna put all the 10 test cases inside one array of arrays. I call it V. I will loop through V, so I will be each individual array. This is the function. I'll just call it F. Receive an array by reference. Call it V. Name doesn't matter. Low is 0. High is v dot size -1. The exit condition should be low must be less than or equal to high. Mid equals to high minus low over 2 plus low. By the way, this function, it has nothing to do with what I'm writing. This is a different function. Now if, because when we need a global variable, global minimum, let's make it start off with max, and the index of global variable 0. In the end, we're going to return global index. If mid is less than global minimum, we override global minimum with mid. We also override global index with mid. If the mid, remember we compare the mid against high. If mid is less than high, we go left. If mid is less than high, we go left. So high is mid -1, else we go right. Low is mid +1. And that's it. Let us do, I call this function f, so let us do f because I wrap it in a solution class. I have a solution class, so this is how I invoke the function. Let us see what we print out. Let's compare against the result 620017053. So we pass all the test cases.